All right, let's see what this thing says. So March 2011, the average size of an HTML, like of a website, was 735 kilobytes. By March 2017, the average size was 2.5 megs. One of the greatest frustrations with websites is speed. Websites are slow and bloated, so as a consequence, users deal with a poor experience, leaving them irritated, but having to make do or move on. To give you an indication of how bad things are, let's take a look through the years at how bloated everything has become. 2012, we had Flash still, Tack, yeah. 2024, average size 200 megs. I will go and find the average size for 2024, Travis. I'm going to keep this open and I'm going to go. This is very short. So you can see most in 2011, most of the size was taken up by images. We continue this trend with scripts and images, number 1, number 2. And we just continue that trend on and on and on. Images got bigger. Scripts got bigger. Fonts got way bigger. I want you to look at fonts. Fonts, 3 KB 2011. By 2014, 55. Style sheets, scripts, HTML. So comparative style sheets, not much. HTML, not much. Scripts, not too much. Then scripts made a huge jump. Then they kept going a little bit higher, a little bit higher. So HTML and style sheets actually didn't budge year over year that often. Oh, damn. Thank you, Arvis. But then 2015 to 2016, they went up by a quarter, over a quarter, almost a third. Scripts. And then you add video. Scripts continue going up. Yeah. In less than 7 years, the average web page has increased around 1.8 megs in size. What we can see is that images are the main contributing factor to the increase in the average size. This makes sense as more websites are using large hero images, more icons, high-resolution gallery images, and retina images. However, this doesn't excuse us. We now have new compression algorithms like Google Gwetzli, I think I remember this, that can compress JPEG images up to 30% of the original size with no loss in quality. We can also look towards replacing image-based icon sets for inline SVG options or lazy loading images, delivering the images only when the user needs them. Okay, another factor of the increase is page weight in fonts. I agree, fonts took a big hit here. In 2011, the average font size on a page was 3 KB, but it is now around 96. A recent addition to larger websites is video. Yep, so that does eat up some of the size. Designers are moving towards richer content, which contains more visuals, interactive content involving scripts, custom fonts, and styling. All this is great, but as a consequence, we could be ruining the user experience. We should not stop producing rich content, but instead optimize the delivery using existing tools and methods. What is the cost of having a bloated website? What sums this up for me is the below image by Luke Wroblewski, product director at Google. This level of stress caused by mobile delays was comparable to watching a horror movie. What? They actually took cognitive load stats? Look at this. Waiting in line at retail store. Watching a melodramatic TV show. Standing at the edge of a virtual cliff. Watching a horror movie. Experiencing mobile delays. Solving a math problem. No. According to the Ericsson Consumer Lab, their research indicated that the level of stress caused by mobile delays could be compared to watching a horror movie or solving a maths problem. Here are some key facts from Kissmetrics blog, which I think it's a subsidiary of the Ericsson stuff. I can't remember. 73% of mobile internet users say that they've encountered a website that was too low to load. 51% say that they've encountered a website that crashed, froze, or received an error. This for when was this article? 2020. Let's assume like maybe 2017, because I don't know what the source of this blog is. Let's assume that in 2017, 51% is the accurate number here. That is depressing. That 51% of websites encountered crash, freeze, or receive an error. 38% say that they've encountered a website that wasn't available. That's insanity. 47% of consumers expect a web page to load in 2 seconds or less. 40% of people abandon a website that takes more than 3 seconds to load. A 1 second delay in page response can result in a 7% reduction in conversions. That is crazy. And just so Arvis knows, that does not mean reduction in sales. It means reduction in conversions, which are higher likelihood of sales. If an e-commerce site is making $100,000 per day, a 1 second page delay could potentially cost you $2.5 million in lost sales every year. The key takeaway is that today's standards are no longer good enough. We can push the boundaries of web design and development whilst creating a fast, responsive website. We shouldn't sacrifice performance for creating a beautiful website. That article was published in 2017 on LinkedIn. Thank you, Omni. Yeah. Yeah. Okay. So Arvis, potentially, it's an extremely pedantic argument. Businesses can do nothing but focus on things that they have sold and things that they can potentially sell. There is no other way to cut it. So the future value of a company is based on potential. How else are you going to base the potential? Like, you're going to have to look at what they've historically done and the numbers that they had to get in order to do those sales historically. And therefore, any impact to those numbers has a potential dramatic impact to their long-term value. You can't really look at it any other way. So yes, it's potentially 2.5 million in sales. That doesn't mean that everything perfect would mean that they would get that 2.5 million. But that potential, if everything done right, is one of the only ways that you can really judge a company's potential and ongoing longevity. The shocking thing about 51% crash freeze, at least to me, is that it's low. I'd have thought everyone would say yes to that. But, oh no, I think that's high, Laugh. Twitch chat input field gets slow for me sometimes. The other day it actually reversed the message. I type in Laugh. What the hell? That's crazy. This is insane. That there's actual somebody thought to do a cognitive load study on. What the hell? Okay, this is actually really good data. And we haven't even got to 2024. So 2024 average page. Okay, here. Is this what 2024 load time stats, average page load time and impact. So I must have had this loaded up before. We've analyzed over 4 billion web visits over the last year to learn more about the factors. Okay. Yeah, well, let's see this. A page load time on mobile of 10 seconds increases the bounce rate by 123% when compared to a 1 second loading speed, according to a Google Industry Mobile Speed Report. Google Consumer Insights also found that 53% of mobile site visitors will leave a page if it takes more than 3 seconds to load. This is 2024. Website conversion rates drop by 4.42% with each second of load time that goes by, between 0 and 5 seconds, according to an experiment by tech agency Portent. Almost 70% of consumers have said that page speed impacts their willingness to buy from an online retailer, a page speed report found. Yeah. Okay, here we go. So 2024. The average web page load time is 2.5 seconds on desktop and 8.6 seconds on mobile. Based on our analysis of the top 100 web pages worldwide, the average desktop first input delay FID speed is 12.73 milliseconds on desktop and almost an entire and 59.73 milliseconds on mobile. Web pages on mobile take on average 70.9% longer to load than on desktop. This is terrible. Across all websites, mobile users have an average bounce rate of 56.8%. Desktop users have an average bounce rate of 50%, and tablet users a 51.6% bounce rates. From our analysis of 4 billion web pages, people using a desktop have the highest average pages per session of 3.4. The science industry has the highest bounce rate with 66.37% on mobile devices. What does this mean? The sports industry has over 200 million sessions year on year on mobile, the most out of any industry. Retail sites get an average of 5.01 pages per session on desktop, the highest out of the 23 industries analyzed. Out of all three electronics, mobile, desktop, and tablet has the lowest number of sessions per year over year of 2.3%. Okay. That's bounce rate. I want to see like load size. Sure. Average session duration. This is good stats, man. Loading speed. Okay, loading speed does not tell you how much you're loading though. For performance scores, the scores of 90 is good. 50 to 90 needs improvement. Below 50 is poor. We have analyzed the top 12 website builders to find out which ones give you the best performing experience. Well, this is damning. GoDaddy. GoDaddy! No! Jimdo. Webnode. Wix. Volusion. Oh no. Webflow. Weebly. WordPress. Shopify. Squarespace. Woo. These aren't great. Best website filter based on mobile performance. Mobile. Dun, dun, dun. GoDaddy gives you the best performance. I don't believe my eyes. Jimdo at 60, and then the rest just suck. They suck. Yeah, Mike. It's your fault. How you doing, man? Best CMS based to TTI. GoDaddy. Oh, GoDaddy's winning everything. Best CMS based on time to interactive mobile. Still GoDaddy. Oh, man. This is bad. Okay. So these are general performance score metrics, which include first contentful paint, cumulative layout shift, first input delay time, speed index, largest contentful paint, time to interactive. The top 15 website home pages based on performance score. Twitter, 100. Best Buy, 99. Okay, these are actually looking pretty good. Performance score out of 100. The worst 15 based on performance score. The worst. NASA fucking 5. NASA sends people to the moon, but they can't get a performance score higher than 5 on their website. Channel 4, Rolling Stone, I mean, you know, Nintendo, I kind of expect more from Nintendo and PlayStation. I would expect a little bit more from Nordstrom because they have money up the butt. Time, I'd probably expect a little more than 40. WebMD, TikTok, I mean, Walmart, GitHub, I would expect to be way higher than 48. Dear Lord. Okay, but that's not what I wanted. I want like 2024 average page size. What am I doing wrong here? Page size. Here we go. Page weight, HTTP archive. Here we go. Here we go. Why is this not working? Why can I not? Here we go. Okay. Let's see. What would we want to check for? Total, I guess total kilobytes. The sum of transfer size of all resources requested by page. So from 2018 to 2024, that's actually pretty good because we just kind of stopped looking at 2017, right? So if we look at it, going back, well, they go back a lot. 2010 to 2024. So median desktop, median mobile, half a KB for desktop, no, half a meg, I mean, and like 1/10 or whatever for median mobile. And in 2024, damn, what's the dip in 2018? I would imagine that in 2018, it would have been stuff to do with, if I recall correctly, there were a few tools that came out to do compression on things that you normally shipped with your HTML, like images and whatnot. And so the heavy usage of these compression mechanisms created kind of like a drop in having to ship things in full force. Like somewhere between 2018 and maybe even like 2020, like right before like COVID days, there were a few tools that came out, like Brotli, I think. Yeah, WebP I don't know if WebP came out in 2018, but maybe around that time. And so there might have been an initial drop where people used it a lot, and then, you know, React came back and said, hey, use us because we're going to do everything right. You don't need to ever use your brain again. And then like everything went up again. Cool, more free space to use. Exactly, yeah. Total requests. Oh, this is interesting. The total, okay. This is actually a banger set of data. What does this tell you? Given what we just saw data-wise here, tell me what this tells you, looking at the number of requests. We're going from like 2011, about 6328, and then in 2024, let's go look at like over here. We're looking at about 73, 74. And over here, this I would attribute directly to the rise of framework usage right around here, where frameworks and like GraphQL and lots of Ajax, you know, REST API calls with lots of requests. But if you just look at the overall from 2011-ish to 2024, Look at the number of requests, right, comparatively, and then tell me what this tells you, number of requests versus number of kilobytes transferred in the same period. Lazy loading frameworks. Yeah. For me, it doesn't seem much of a deal alone. Here's what it tells me. It tells me that given approximately the same number of requests, what we're really doing is shipping more data per request, more and more and more and more as each year passes. So for every given request we make, instead of increasing the number of requests, what we're really doing is increasing the amount of data we ship per request. That also tells me that along with that comes subsequent complexity. So imagine back in, say, 2011, your JavaScript size per request was like 100 KB. And now in 2024, your JavaScript size per request is like a meg. That also means that you're actually running more code, which means that your browser is doing more, which means that along with shipping more data per request, that then following up to that, you're doing more after that request. Let's just blame React and TypeScript. Oh, I completely do. Completely. I completely blame them and things like them. But let's blame React. I wonder how much of that is due to transferring data like JSON. Probably a lot. Probably a lot. I mean, people add libraries for shit like left padding. Yep. CSS bytes. Holy cow. However, this looks like a huge jump, right? This looks like a huge jump. You're like, whoa, that's like a 7 or 8 time multiple. But it's still so low. So low that this almost doesn't matter. I don't, you can make an argument that it shouldn't be this way, but just in total, even now, it's still extremely small by comparison. CSS requests. That's it? 2 to 3 to 8? That's pretty good. Font bytes? Holy crap, look at this! What? What were we smoking in 2013? And that's just 2013. Look at this! Look, in 2013, we went like super high. We're like, yeah, smoke that text FS drug. And then we made a precipitous drop. This looks like crypto, honestly. This looks like crypto stocks. The history of Bitcoin right here. Okay, font requests barely changed. So the same number of requests, just wild variation. HTML bytes. Let's see. Come on. Okay, this is very interesting. Really? Okay, so we start in 2011, pretty small. We kind of go up a bit, but not much, eh? And then we have a precipitous drop here, followed by a precipitous increase. I wonder if this is React. I wonder if it's like JavaScript will do client-side rendering who needs HTML, and then you go down like that, right? Because you don't ship as much HTML. And then people go, wait, this was a terrible mistake, and then you come back. But that would have been all in like less than a year. I don't know if that's true. Can we compare this to JS bytes? Sure. So at the high end, 33.2, 31.9. JS bytes would be, where is it? That's font. That's HTML. Image bytes. There, JavaScript bytes. $639, $583 respectively. Holy crap. I say that's from HTMX, the end of the graph for HTML. Maybe, possibly. Yeah, Travis. But this just means websites are more or less the same size as before. Or that they contain more or less the same website, like in essence. But we're shipping more crap. The URL for this? Sure. One sec. That is a sharp increase at the end, yeah. Yeah, just one sec. Let me get the link in here. There you go, Omni. Look at what the curve is beginning to do. Yeah, it's beginning to go up. Yeah. Sharp increase, yeah. So if we like zoomed in, let's zoom in, right? Yeah. I think we write the same amount of HTML we did before, but ship more JS along with it. Yeah, I think that's right. The CEO curve, yeah. So JavaScript requests have been like kind of stable, I guess, going up near the framework days, like jQuery, you know, Angular, Backbone, etc., and then React and other shitty shit that got shitted out and was promised the world for you, and then it just, you know, here you are. Other bytes. The sum of transfer size kilobytes of all unidentified resources. Unidentified resource is one that does not match a known script, font, image, style sheet, XML, video. Okay. Wait, what? Okay, but it's still like negligent. And then other requests. And then video bytes, of course it's going to go up. Of course. Okay. Yeah. You're missing the mouse over notes along the date lines? I see. Right. Mobile CPU throttling. Okay, good call out there, Omni. Let's just go back. Let's just see if there are interesting notes. So this would be total KB. Increased number of URLs, yeah. Desktops, yeah. Mobile 3G. Accidental IE11 update. I don't know what that means. Agents. Desktop data loss. Switch to Linux. Oh, okay. Switch to Linux test agents. I see. Oh, so the URL structure change made an impact? I think it's time to have just an immediate mode GUI available in browsers. Yeah. Kale, I agree. I agree. Corporations need to take a fucking chill pill. We need to GTA some corporations. That's what we need to do. It's the programmer version of GTA corporations. We need to walk in and we need to just wreak fucking havoc. Just like run over the strippers, okay? You know, like all the just like randomly Just fucking just go ham. Just start destroying shit. Don't care about the consequences. Full fucking GTA and yeah, RPG rocket launcher that shit, right? And be like, listen here, corporate fucktards. You need to take a chill pill. And until you do, we're GTAing the shit out of you.